Welcome to our presentation with the headline Digital Twin and Mechatronic Change Process. Markus and me, we build up a showroom to present you this common solution. My name is Martin Santen. I'm working at company Zuken. I'm responsible at Zuken for the ECAD team. And now I'd like to pass over to Markus.
Hi Martin, I'm really happy to be part of our joint showcase here. My name is Markus Fleckenstein. I'm with PTC and I'm responsible for business development in Central Europe when it comes to electronic and high tech and also for Arena PLM. So I'm really excited to showcase this system connecting showcase using the different mechatronic disciplines from Zuken.
So now let's start on our racetrack for the implementation of such an example change that we just described. So we will start with a product innovation request that we used, where we used a normal Windchill object to create this kind of innovation request that we want to further proceed. And we can see there are many of them for review. And for this specific one, we talked about the additional power upgrade as described earlier as a theoretical example, which requires some updates on some components and some products. Probably that's why we included also a change request already. So it seems it's already progressed a little bit. Someone moved this innovation request further so that we can now have this change request, which is then officially proposing solutions and estimating efforts and so on. In the next step, we will take this change request and further detail this out, because from the change request we will move into a change notice, so basically the execution of the change. And this is already prepared because we don't want to have this as a typing exercise here. It should be a demonstration on how this all works together. So therefore we have already prepared a little implementation plan which goes through all the different disciplines. So software disciplines, so there might be need for a new software version. We probably need to have additional cable routings and harness changes. We need to probably add a space in the mechanical design for this control unit, and we also need to modify and update the control unit to add the GSM module. And then we have the different tasks that can be defined and can be further detailed, right? So including which design tool they should be used, or is there a review required, and also some more detailed description information. For example, that we need to modify the harness. This could include some pictures, some text, whatever you might need on the expert system side, like on the DSCR, DSE3, to further work on that. So also resulting objects, affected objects can be handed over so that this is then all available for the electronical designer to work on his job and to further detail this out basically in the expert system, which we will see then later. And so even for where we can have this control unit, this has resulting objects included, but like in this case we just described that the further detailing might be required on the expert system side, right? So really brings everything together. Affected resulting object can be prepared, can be handed over, and as soon as the implementation plan is completed, we can send the whole implementation plan or the whole change notice for execution. Though that means currently it's just planned, so we need to submit it. So the submission takes place, so it moves from open to implementation, and we used a little workflow in the background using our ThingWorks flow to send information to the Zuken interfaces so that they are triggered and they can then identify what additional information is needed, and using their integration capabilities to pull all that information in the relevant system. And with that, let's move on to the specific disciplines. So handing this over to Zuken and see how on the Zuken side this all progresses.
Great, thanks, Markus. Now you have shown how to implement the implementation plan in Windchill. I now take the time to present the parts, what is to be done at DSCR. So in next step, let's see how the implementation plan looks like at DSCR. It's design related, so related to this bike, the Super Duke, that the implementation plan is part of the DSCR environment. So we select the related schematic circuit. Here you see the implementation plan. You have the chance to open directly via the browser the Windchill environment to have further details related to the implementation plan, which were shown before by Markus. And the hardware engineer has then, of course, the opportunity to check out the design for any kind of further editing. And here we will open the schematic design that the module, which should represent the new functionality, is not available now, but will be placed in a later step. So we open the schematic number 9. And here is the hierarchy block actually missing. So, but before using a hierarchy block symbol, we have to talk about subtasks. Subtasks is the information what is to be done by the ECAD team members, the hardware engineer, the layout team, etc., and how the subtasks look like at DSCR. Means the electronic design team is maintaining those subtasks. They are again design related, so that after implementing the subtasks, you have still the implementation plan, which has still access to Windchill. We show it again. And all those subtasks, you have the opportunity to define all requirements and add optionally also documents describing further details. So we open one of those subtasks, the subtask number 3, and this is for verifying the functionality of the GSM module to the app from KTM. So this is the PDF document representing the new KTM app, which should bring up the new functionality that the cyclist has a chance for temporarily more horsepower. Okay, then, but we have to do, of course, the standard functionality inside of DSCR and CI1000. So let's take a look what is to be done to implement a module. The module is being prepared upfront by a modular library team or the same user, doesn't matter. And we want to reuse this functionality. So with the reuse, it's in this case pretty easy. You drag and drop the module from the module library to your design. The DSCR says it's a reuse, and you take it as a module exactly in this version, which is described in the library. And if this module will be maintained and updated in the library, you have this reuse information available in DSCR with any checks and update opportunities which are required to update your actual design, or later, if it's archived, also your archive design. And in a further step, we open again the sheet number 9, because what is still missing is the hierarchy block symbol. So the hierarchy block symbol can be placed by standard functionality. It's place circuit block. It's a part of the design data. So we change to in design. You see now this hierarchy block symbol is now became available with reuse functionality, and place it. And in further steps, you have to do the checkings, the electrical connectivity, etc. So now 4 further schematic sheets be part of the schematic. And then later, when the check's been done successfully, we will check in again the complete design. And you will see that now there is a module be part of your design. Yeah? So the check-in will be done. And then we take a look to the version history of this block found in the design and where it comes from. You have exactly this information where it comes from and in which version it's been becoming maybe available, so that any update procedure is possible later. Okay, now we have to do, of course, the job in the layout. The challenge is here, which is part of the subtask description, that the new devices, the new functionality should be still become a part inside of the existing housing. Maybe a real challenge, and therefore, of course, you have full functionality available in design force, after forward annotation, floor planning, routing, to make, let's say, also an import of the mechanical housing and checking if any minimum distances are kept between the layout and the housing, and that it really fits to your design and follow all electrical, electronic constraints which are required by this design. And after this design is being also checked with all checked functionality, we have to do, let's say, as a final step, the transfer of bill of material and preparing new manufacturing documents, PDF documents, and describing those documents and transferring them from the SCR to Windchill. If the, let's say, purchase department is not using DSR, maybe it's using then Windchill, have complete access to this data. So, okay, so in a further step, we take a look to the part list editor, which is a functionality inside of the SCR. So the bill of material is then visualized for this design, for the new variant, which becomes part of this design. Let's take a look to the part list editor, and you have then access to all electronic data. And what is also imported by the Zuken PDM connector is information coming and be maintained in Windchill. So we have here in the green column released not only the DSCR status, we have also the Windchill status available. And we want to pass the destination 12 bill of material to Windchill. Transition is completed. And let's take a look to the result, what is found now in Windchill. This design has several different variants, and in Windchill you can see it as a structure assigned to this bareboard, and the destination 12 has also this kind of structure in this classification tree, in the structural tree, with all related information. Okay, and then the last step, after preparing with our DSCR document generation tool, also we have to transfer those documents, and these documents can be part of the design folder, and we want to pass, in this case, a PDF document from the SCR to Windchill. And we select this PDF document and the related folder. And the related folder has already the information with the linkage to Windchill, which is important and necessary to transfer assigned articles, means in this case documents. At Windchill, the related article has actually no document available. This is still empty because it's an initial transfer. And the related PDF document, or maybe plural, several documents, can be transferred all at once. And this single PDF document also has no information of Windchill. After the transfer, this information is being transferred back to the SCR. So now we have inside of the SCR, if you take a look again to the property menu, the relationship means the relation number 930, and after updating and refreshing the view of this destination in Windchill, you will see that there appears now a document. This is the document 930, and you can have a view of this document also with this functionality inside of Windchill. So, and the purchase department has now complete access to all the data which are required to, let's say, do the purchase, right? Okay. Then I want to pass back to Markus that he's presenting what's going on later then after the ECAD team has done his job at Windchill site.
All right, Martin has completed all his tasks, so everything seems to be done on the DSCR side. So all design information was modified, updated, transferred, and so on. So we just need to update the changes, the change objects on the Windchill side. So when every single task from this change notice is completed, then we will get a workflow step to audit this change notice, so to check if this mix of multiple disciplines was successful, and if everyone has done the job that he had to do, and if all information is now valid, so we can have the similar information about all the impacts and everything, but we won't go through that in any detail during this demonstration. We basically just wanted to highlight that if we complete the task of this audit of the change notice, because we think everything is okay, everything is fine, this will also then further have an impact on all the associated upstream processes. So now the change notice is resolved, as you can see in the upper right here, and as this change notice still is aware that it came from this change request. The change request is also resolved, as this arrow indicates over in the right corner, and then we also see that this innovation request that we created initially is also resolved. So from a process perspective, everything is fine. All steps are completed, and now everything is okay, and we can basically further continue with other development activities that might be required, or that other change processes that might be required with implementing this new feature, or we just can go ahead and maybe release the product into production.
So in this showcase, we have now seen how we can connect multiple disciplines with a single process. So it's really helping the collaboration about cross departments. So building a full-blown bill of material containing all the mechatronic information from Windchill, from DS, DSCR and DSE3, so that we can really speed up our change process. So build up a connecting world with different environments, different disciplines, really helps a lot to drive innovation and to be quicker in implementation. So it was a real pleasure to build up this use case, and I was really happy to present it today together with you, Martin. Thanks a lot to the audience for attending and for your interest. And in case there are any questions, please feel free to contact us.
Yeah, Markus, great thanks to you. And it was really a pleasure to prepare this showcase together with you. And also great thanks to the audience. And I wish you, of course, a lot of pleasure and further other presentations at Zuken Innovation Digital. Please take the chance to have, after this presentation, a discussion with us if you like, and let's see there all together. Thank you. Bye.